Okay, in this video, we're going to be going over page 19 of your toolkit. We are looking at inscribed angles in a circle. So if you look here at this diagram, this could be an example of an inscribed angle. This angle right here is inscribed because the angle is on the actual circle. So it's not a central angle, it doesn't come from the center, it's actually on the circle. So this angle here is inscribed, so therefore it is half of whatever our central angle measure would be. So we could say that the measure of angle ABC, so I'm going to call this ABC. I guess you could also call it angle B. There's really only one angle at angle B, but there's some other overlapping arcs and circles around it. So I'm going to call it ABC. We would say that it is equal to half of whatever its arc is equal to, which is also the central angle. So we could say it's half the measure of arc AC. I'm sorry, I didn't put half in front of that. Half of AC. I said half, I just didn't write it down. The other way to look at it, so let's say, for example, let's say this is 80 degrees. This part of the circle, if we're going around the full circle, would be in 360. This part is 80. Let's just, for example, say that. That would make this angle here 40 degrees because half of 80 gives us that value of 40. So one way to look at it is by taking half of whatever our arc is equal to, or we could also say that the measure of arc AC is equal to 2 of these central or these inscribed angles, 2 measure of angle ABC. So depending on what number you're starting with, you might want to double a value or might want to divide a value in half. So if we're starting here with 80 degrees to figure out the inscribed angle, we would divide that by 2. Or if we're starting with our inscribed angle, we could double that to figure out our arc angle measure. Okay. So an example of us using this problem would be here. We have a 46-degree arc. That's this arc KM. Therefore, that means this inscribed angle here would be half of that. So we should be able to say that 7x plus 9, that's the inscribed angle, is equal to half of our arc, which is 46. So now we're just solving an algebraic problem here. Half of 46, that would be 23. So we would say 7x plus 9 equals 23. We can subtract 9 on both sides. That would give us 7x equals 14. And then x is 2. Okay, and in our next diagram, we are also looking at inscribed angles, but we're looking at inscribed angles. We have multiple inscribed angles, as we can see, that intersect overlapping arcs. So we're going to kind of label this overlapping arcs. So let's look at and compare angle A and angle D. And if you notice, when I trace angle A, the arc that it goes to is BC. And if we trace angle D, it also lands at that arc of BC. So these both have this arc in common. What that means is they have to be equal to each other, therefore. So I should be able to say that the measure, I am just going to call it angle A for this diagram, is congruent to angle D. And I'm just going to put in parentheses, the reason is because they both overlap or go to arc BC. And then the other two angles that would be equal, we can call them B and angle C. If you notice, when I trace angle B, it lands at from A to D, and when you trace angle C, it lands in the same place there. So they both have AD as their overlapping arc. So I should be able to say that angle B is congruent to angle C. And that's because they both intersect AD as their arc. So just put those in parentheses. So now if we look at our diagram here, we are solving for x first because we want to figure out a measure of an actual arc. So first step would be noticing, okay, these two angles, V and Y, all right, they both land at the same spot. So they both land at this arc here. So I know that they need to be equal to each other. So my first step is just going to be setting 6x minus 7 equal to 10x minus 47. So now we could just, get all of our x's on one side. I'd probably subtract 6 on both sides first, just so I'm working with some positive x's. And then now that all my x's are on the right side, let's bring all our numbers to the left side. So let's add 47 to both sides. So this will evaluate to 40 equals 4x, and 4 times 10 gives us 40. So that's x equals 10. But we were also looking for the measure of arc WX. So that's this arc here. So if we take this 10, and we're going to plug it into these angles here, well, I could do, well, so that's 6 times 10. That would be 60. 60 minus 7, that would be 53 degrees here. Now, if you plug it into this angle measure as well, 10 times 10, that's 100. When you subtract 47, oh good, that's also 53. So that also is another way to verify, did I get my answer correct? So if this angle here is 53, this arc is going to be double that amount, kind of looking at back to this idea here. So if I take 53 and we multiply it by 2, that will be 106 degrees. So this is the arc angle measure that we were looking for, 106. So the 106, remember, is just in terms of the entire circle being 360. This is 106 of that degrees. Okay, and then our last thing here, we have an inscribed quadrilateral. I'll just abbreviate it, inscribed quad. So in the lesson, you looked at this a little bit as well. What you were noticing is that the angles that are across from each other, angles A and angle C, those two angles together will add up to 180. So angle, let's put measure angle A plus measure angle C equals 180. And then the other two angles that are across from each other, B and D, so measure angle B plus measure angle D also equals 180. And the reason for that, I'm just going to put two little dots here. It doesn't necessarily mean that they're equal to each other, but we were just looking at these two, they're opposite and across from each other, and then these two, they're opposite and across from each other. And the reason for that is if we essentially look at angle C where it lands here, and angle A where it lands here, essentially where it's landing is, they're landing at spots that will fill up the entire circle. And if we fill up the entire circle, that's 360. So if we then take half of that, that would be 180 for the angles that are inscribed to that actual circle. So now looking at it in our diagram here, we're solving for x. So let's see what we have. We have this angle here. And actually, this could probably be solved without using our inscribed angle theorem. We might add an element to this that would require it. But what I'm noticing is that the full entire circle has 360 degrees. We have 91 degrees. We have 135. So this part here, what's left of that circle will be 360 minus 91 minus 135. So this will be 134 degrees. And then this angle is inscribed to that. Okay, so 134, this angle measure will be half of 134. So we can then take 15x minus 23 and set it equal to half of 134. So from here, we can get 15x minus 23. Let's set that equal to 67. We can add 23 to both sides. So 15x is equal to 90, and then x is equal to 6. So let's actually maybe add an element to this question so that we can use our inscribed angle theorem just a little bit. Let's go ahead and plug that back in and figure out the measure of angle L. So let's multiply 15 times 6. That's going to be 90 minus 23 is going to be 67. So this angle here is 67. These two would add up to 180. So 180 minus 67. This angle here would be 113. And then if you wanted to double check and just make sure, if I doubled 113, that would be 226. So from here to here, that should be 226. So the other way to verify and check that is 91 plus 135 is 226, in fact. So we just kind of added this little question. We already had solved for x, yes. We got 6, great. But we added a little element to incorporate our inscribed quadrilaterals that we just learned. So these two opposite angles add up to 180 is what we're really looking for.